In this video, I'm going to teach you how to find and use the distance formula. I'm making this video because my daughter Caroline is sick, and so I'm not going to be in class today, and I want to make sure that we are moving ahead and learning everything that we need in order to keep this unit on track so that we end on time. So I do expect you to be taking the notes for this video in your spiral. And if needed, you can ask the substitute to pause the video so you have a little bit more time to write down before we continue. And then there's going to be a worksheet for you to practice this skill. And my substitute is going to collect that at the end of class, and I'm going to enter it in as a classwork grade, so like a homework grade, when I get back. So, we are writing notes. This is how to find the distance between 2 points, and you're setting up just a basic sketch of a graph. On that graph, we are going to plot 2 points. We are going to plot them at the following coordinates. So you're going to plot the coordinates at 4, 4 and 2, 1. Do that now. Okay, and so now we are finding the distance between those 2 points, which can also be thought of as the length of the line segment that connects those points. So given what we learned yesterday about the Pythagorean Theorem, we can turn this line segment into a right triangle and then use the Pythagorean Theorem to find the distance. So to turn it into a right triangle, we would just follow the lines on the grid. So we could have one leg be here and another leg be here, so that the hypotenuse is the segment that we want. See, now we have a right triangle. So go ahead and find the length of the hypotenuse using what we did yesterday. So we know that our leg lengths are 2 and 3. The Pythagorean theorem says that the legs squared and added together equals the hypotenuse squared. So we're going to do 2 squared plus 3 squared equals c squared. So that means that the length of the segment here is the square root of 13. Okay, so this is great. You can always do this to find the distance between 2 points. However, if I asked you for the distance between 2 points that are very far away from each other on the graph, or perhaps there were decimals involved, or just things that you didn't actually want to graph, we want a shortcut way to do this that doesn't involve making the graph first. So we need to find a way to come up with that 2 and the 3 based on the coordinates. So let's say that instead of 2 points, or let's say that we're going to use 2 general points. So we're going to use x1, y1, and x2, y2. See if you can write down how you would find the length of A and the length of B based on those general coordinates. So write a formula for it. So if we had our 2 points, x1, y1, and x2, y2, and I want us to find the distance between them, then I need to find the change in x values and the change in y values. So the change in x values could be x2 minus x1, and the change in y values could be y2 minus y1. It should feel kind of familiar, right? Sort of like what we do with the slope formula. Except instead of dividing the change in y by the change in x, we're going to plug those in to our Pythagorean theorem. So now I've got my a squared plus b squared equals c squared. And a now is x2 minus x1. And b is y2 minus y1. So I'm going to plug that into my formula and then solve for c. So I have my x2 minus x1. I'm going to put it in parentheses and I'm going to square it because the a was squared and the entire a is now an x2 minus an x1. And then I'll do the same thing for b, which is y2 minus y1 squared, and that equals c squared. So I just have one more step, because if I'm trying to find a distance, then I don't want the square of the distance, I want the distance. I just want the length of c. I don't want c squared. So for my last step, I'm going to take the square root of both sides. So I'm going to take the square root here and the square root here. So my final answer, my final formula is going to be c, or I'm actually not going to write it that way. I'm going to say the distance is going to equal, and then I'm just rewriting everything I wrote up top, the square root of x2 minus x1 squared plus y2 minus y1 squared. And now, if I were there, we would spend some time talking about how you can reverse the x2 and the x1 as long as you do that with both of them. All right, just like in slope, it doesn't matter which order you subtract as long as you're consistent with both. As it is though, I'd like you to copy down this formula exactly the way I have it written so that you can make sure that you're applying it correctly. All right, let's go ahead and do a practice problem together before you start on the classwork. Okay, so you're going to do 2 examples with me. So first, we're going to do one that's small enough and on the grid that we'll be able to check it graphically to make sure it makes sense. So you're going to use the point 0, 1 and -4, -2. And you're going to find the distance between those 2 points using the Pythagorean theorem. In other words, using our distance formula. Go ahead and try it now. So just like when I'm working with slope, I'm going to start by labeling my points, x1, y1, x2, y2. Then I'm going to plug into my formula. So here's my formula, and now I'm going to put in my values. So instead of x2, I'm going to write -4, and then minus x1, which is 0. I'll square it. This is all underneath that square root. And then I'll add it to my y2 value of -2, and then minus a 1, because it's a positive 1 over on the y1, and that's squared as well. So then I have to do that. So -4 minus 0 is just -4 squared, and then plus -2 minus 1, that's -3 squared. I'm going to take the square root of that. And so now I'm going to do my squaring. So -4 squared is 16. 3 squared is 9. Still taking the square root. 16 plus 9 gives me 25. So I'm doing the square root of 25, which is 5, which says that the distance between these 2 points is 5. So I'll go ahead and plot my points, make sure that looks reasonable. So 0, 1, and then -4, -2. And then I'll draw my right triangle. This is a 3 by 4 triangle. And if I do my Pythagorean theorem, this side does in fact end up being 5. I actually know that because it's a Pythagorean triple, which we'll talk more about later this unit. So it's true, it worked. Okay, let's go ahead and try it with the messier numbers now. If you haven't had a chance to do that, you should probably pause now and take a chance. Okay, so let's plug our numbers into our formula. So I'm going to do my y2 minus y1. So 210 minus 200 squared plus my y2 minus y1 squared. And of course, we're following order of operations, so we're going to do the subtraction first. So I've got 10 squared plus 3 squared. Still doing the square root of all that. And that gives me 100 plus 9 under the square root. So I'm doing the square root of 109. You would then check to see if that could be simplified. I don't think I can, but please do prove me wrong, as our distance between these 2 points without ever needing to graph them. All right, so now you're going to be working on a practice worksheet. It has a front and a back. It's going to be collected at the end of this class. You're not going to be able to finish it for homework. You're going to collect it at the end of this class, and then it's going to be entered in as a classwork grade. So keep yourselves on task, help each other as needed, stay focused, get it done. The homework tonight is Khan Academy. It's called Distance Between 2 Points. It is going to be practicing this skill again. I'm also going to upload this video onto Google Classroom so that you can watch it again at home tonight if you need to, if you would find that helpful. If someone could write the homework up on the board, if it's not already there, that would be great. I would really appreciate it. And hopefully I will be back in class with you again tomorrow. If not, I will have another video for you. Happy mathing.